ready to turn your Python functions into network-accessible tools that AI models can call over HTTP. You'll see how to create a FastMCP server with a single tool, then deploy it as an ASGI application, making it instantly available to clients and AI systems over the web. The pattern is simple. Define your tools, wrap them in FastMCP, and expose them via HTTP with just one line of code. From FastMCP, import FastMCP. MCP equals FastMCP, my server. At MCP, tool. Def process data input, SDR. Process data on the server. Return F processed, input. Hash create ASGI application. App equals MCP, HTTP app. This demonstrates the ASGI application pattern for deploying RPC services as web endpoints. The code transforms a FastMCP server into a standards-compliant ASGI application, enabling integration with any ASGI-compatible web server like Uvicorn or Gunicorn. What makes this distinctive is the separation between service definition and deployment strategy, letting you focus on tool logic while deferring transport decisions. The pattern works by encapsulating the RPC server as a mountable web component. Your decorated tools remain pure Python functions, while the framework handles HTTP routing, protocol negotiation, and session management through the ASGI interface. This creates a clean boundary where your business logic stays framework-agnostic, and deployment details become configuration rather than code. This approach solves the production deployment challenge for RPC services. By adopting ASGI, you gain immediate access to production-grade features like worker processes, middleware stacks, and reverse proxy integration without modifying your core logic. It's ideal when you need to scale beyond local development, integrate with existing web infrastructure, or deploy alongside other services in a unified application. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable tools. It handles the bridge between Python functions and AI models, managing serialization, validation, and execution. MCP equals FastMCP, my server. This instantiates the FastMCP server instance named my server. It's the central coordinator that will register all your AI-callable tools and handle HTTP routing when you build the ASGI app. At MCP, tool. Def process data input, SDR. Process data on the server. The @MCP tool decorator registers this function as an AI-callable tool. FastMCP uses the type hints and docstring to auto-generate the tools schema, ensuring the AI understands its input-output contract and purpose. This pattern exposes Python functions to AI models while maintaining strict type safety. Return F processed, input. This formats the input string into a processed response, demonstrating the tool's transformation capability. The F-string pattern ensures type-safe string interpolation while maintaining readability, a common practice for tools that modify data. Hash create ASGI application. App equals MCP, HTTP app. This creates an ASGI-compatible application from the FastMCP instance, enabling HTTP-based tool execution. The app handles routing, serialization, and error handling automatically, exposing all registered @MCP tool functions as API endpoints. This is the standard pattern for deploying FastMCP tools as a web service. ASGI application pattern. The MCP, HTTP app, method transforms your FastMCP server into a standard ASGI application, enabling deployment with any ASGI-compatible server like Uvicorn or Gunicorn. The ASGI app path defaults to /MCP, but this can be customized during deployment configuration. This pattern bridges FastMCP's tool-oriented design with production-grade HTTP infrastructure.
The server that becomes an application loses its name, but gains every path